So in the previous videos, we've gone from a point A to a point B. They were both given and we found a fixed arc length. Right now we're going to create a formula. So we're going to start at A, but then our arc length could end there, or it could end here, or there, or there. But basically we're going to go to some X and then find that total distance from that X. So it gives us a formula to allow us to plug any number we want into that. And this is what we use for our formula. And so this is just notation. We're going to take it the same way. This is just our y prime. And then when we get to using this point, we'll change it to a t so that we can plug in x in at the end. Sound good? Perfect. So we take our derivative. So this is 1 over sine x times, and then it's chain rule. So cosine x. That's cosine x over sine x, which is cotangent x. Next step is we square it, just like before. So we get cotangent squared x, and then we add 1. So we're just working our way out just like before. We find our y prime, we square it, we add the 1, and then we'll square root it. So there's no difference here. And so that would just become cosecant squared x. So now when we square root it, we just end up with the square root of cosecant squared x, which is cosecant x. And we should put an absolute value around it because when you square root a square, you get a positive. All right, so now we're going to take and plug it in. So our s of x that we're trying to find will be from pi over 2, because that is our starting point. We are starting at pi over 2, comma 0. And then we're going to go to x. Now our x is between 0 and pi. And so between 0 and pi for sine, which is our reciprocal of cosecant, we're going to end up with a positive. So we can just use cosecant x here. We don't have to worry about the absolute values. But instead of x, we're going to use t, because you can't have an x and plug in an x. So t dt. So we're just changing the letter so that it works. Now we just need to integrate and plug in our letters. So we know the integral of cosecant t is natural log of cosecant t minus cotangent t from x and pi over 2. So from pi over 2 to x. So now we're just going to plug in the x and then the pi over 2. So we have ln cosecant x. So see, now we have a formula. So we're just basically saying from this value to this value. Works the same way. Cotangent x, now we have an endpoint, minus our beginning point. So ln cosecant pi over 2 minus cotangent pi over 2. And cosecant's a reciprocal of sine, so that would be 1. And then cotangent would be 0 at pi over 2, because that's the center point. So we end up with this becoming ln of cosecant x minus cotangent x. I meant by the center like your graph. We go from 0 to pi, and so the center is pi over 2. And that's where we had 0. So this is minus ln, and then this would be 1 minus 0, which is 1. And the natural log of 1 is 0. So our answer would just be natural log of cosecant x minus cotangent x. Okay, so now that we have a formula, how does it work? Well, we can only go from 0 to pi, because if you were to plug 0 in here, you would get sine of 0. ln of 0 is not good. Plugging in pi would also give you 0. So ln of 0, not good. So we're getting vertical asymptotes at both 0 and pi. So if we look at our calculator, I've already graphed it. I plugged in our main function that we're looking for the arc length of, and then our arc length formula. So if you look at the graph, now if I do trace, and we go over here right at that middle point, which is 3 pi over 4. So 3 second pi divided by 4. We end up with this. So it's negative 0.0. And so that is just where we are on the graph. That's all it is. It's just a point. So it's pi over 4 comma ln of rad 2 over 2. So we want is the red. And so that would be our arc length from our starting point, which is pi over 2 right in the middle, right there, all the way to 3 pi over 4. So from pi over 2 to 3 pi over 4, we had an arc length of 0.881. All right. So now if we went the other way, trace, second pi divided by 4, you'll see it comes out negative. of the same thing. Oop, wrong one. Of course, it's negative, right? It's the same thing there. All right. So anyways, back here we get to see it's a negative version of that same 0.881374 because we're going from pi over 2 backwards. And so these two would be switched. And if you remember what happens when you switch them, that's right, it makes it negative. So since we're going backwards, it's negative. So that arc length there from pi over 4 to pi over 2 would actually be 0.881374. So now we have a formula, and if it goes backwards, we just change the negative to a positive. It goes forward, we change the positive. You can see it's increasing here, the arc length, because as you move through this graph, your arc length should be increasing because you're getting farther and farther down the graph. And so that's our formula. From 0 to pi, that's why it doesn't have the equal sign there, vertical asymptotes. And we have a pi over 2 starting point.